Okay, I want to answer a question blackpenredpen posted at the end of his very interesting videos about double factorials. To my opinion, this answer is already correct answer, but I have a own very nice solution, and here it is. Okay, what we have is two divergent products, 1 times 3 times 5 and so on, over 2 times 4 times 6 and so on. Okay, but what is meant seems to be that and we have 2 times 1 minus 1 over 2 times n. Okay, and we want to know where this, what that will be. What I will try is to transform that in a sum. So we have a product 2n minus 1 over 2n, and that is e to the logarithm of 2 times n 1 over 2 times n. Okay, and we know if this is e to the sum 1, okay, of, okay, this is the logarithm of 2 and minus 1, 2 times n. Okay, and what we will do is to look after that. This is a sum, S n, or the limits of a sum. Okay, and we look for that. N equals 1 to n minus logarithm of 2 times n minus n, 1 over 2n. Okay, this is the same than that, just negative. If we want to know whether that converges, we can take the integral from 1 to n of, okay, we need another transformation. This is here, and 1 to n. We just change 2n over 2n minus 1. Okay, so we have the integral of the logarithm 2x over 2 times x minus 1 x, or that one here, minus logarithm 2x minus 1 x. Okay, This is a bit oh, we have to be a bit busy here. Okay, we get x times logarithm of 2x minus 1 minus x times logarithm of 2 times x minus 1 minus 1 plus a half of 2x minus 1 minus a half. Okay. From 1 to m. Okay. This is x times logarithm of 2x over 2x minus 1 plus half of the logarithm of 2x minus 1 minus 1 over 2 from 1 to m. I put those both together and so it gets somewhat easier. Okay, and now what do we get? M times logarithm of 2m over 2m minus 1 plus 1 over 2 times logarithm of 2m minus 1 minus 1 over 2 minus 1 times the logarithm of 2 minus 1 over 2 times the logarithm of 1, which is 0, plus okay. What happens is if m goes to infinity? Okay, we need a name. This is I. This here is at least positive because 2m is bigger than 2m minus 1. This here is finite, negative but finite. So this here goes to infinity. So what we get is Im goes to infinity. Okay? And now if we go back, that means that this here goes to minus infinity. Okay? And accordingly, the product here is 0. Okay, I just want to stress there is already another solution, and to my opinion it's quite perfect. But I like my version very much, so this is here. Here it is.